My name is Ken Riley from Copperland, and I invite you to watch the next exciting video on the origins of gold, part 5. So, the Earth used to be a perfect sphere. There were no mountains, there were no islands. You had a perfect sphere without mountains, without depths, and the sphere solidified on the surface. The sphere was actually what? Granite. Now, granite is a composite material. Granite has a lot of different elements in it. It has quartz in it, it has mica, different elements in it. But the fact is that the entire surface, you can go anywhere in the world and find granite. Because the entire Earth at one time was one continuous sphere of solidified granite. Now we see that if you go to Europe, you'll see that most of the mountains in Europe are like upturned. If you go to where the plates are, one plate is moving and the Mediterranean plate is moving underneath the European plate, you have these mountains coming up, being pushed up of solid granite. The European mountains are pretty unique. It's a lot of granite. If you look at everything that's going on around here, your basic plates are granite. Your mountains out west, any mountain range has a lot of granite in it. But at one time, if you look at it, at one time that granite was flat. And when you had either the Pacific plate coming under the continental plate, or up here you have an eastern plate. I believe it's the something out east coming under the Lake Superior plate. Well, then you have upheavals of your granite and rock layers. We'll get into copper mining later. That's really unique. Copper mining is a really unique place up here. And anyway, as the Earth began to cool, the outer surface solidified and had nowhere to go. It couldn't continue to compress, so it began to shatter as everything shrunk smaller and smaller. This granite mantle began to fracture into all different plates. That's where you get the plates from. And as these plates moved, you had one plate coming in here under another plate. It forced this plate up into a mountain range like that. So you have different mountains around the world being pushed up. You have really two kinds of mountains. You have volcanic mountains made by volcanic activity, which is something different. And then you have mountains created by one plate shoving another plate up in altitude. So you have uplifts and you have volcanics, and you can see the difference pretty easily. It's easy to spot the difference. An uplifted plate or mountain will look like this. And that simply shows that this plate is lifting this plate up, and it's lifting up that high. The other kind of mountain is volcanics. And that's where you have a volcanic mass. You have molten material down here pushing up and creating a volcanic mountain. Those are your two main mountains. Okay, so from here, we'll talk about what's going on with the mountains out west. Our favorite place to study is Arizona. That's our favorite southwestern area. In Arizona, you have these two kinds of mountains. You have the upturned granites, and you have volcanic intrusions and extrusions. Now, an intrusion is simply a flat ground like this. As your magma begins to come up from the core, it pushes up on what they call the country rock, and it turns it into a kind of a hill. This magma is basically a chamber of molten material, but it doesn't ever come out the top of this hill. It creates the hill, and then it stays inside of here, slowly cooling down and creating big crystals. The other kind of volcanic activity is what they call extrusion. That's where your magma comes up, and it pushes up usually a much higher angled hill, and it actually breaks the surface and creates either a ridgeback or a cone plug. Yeah, you see a lot of volcanic plugs out in Arizona, but also a lot of ridgebacks. Ridgeback is where the earth was cracked. As your magma came up, it created a crack, and then from that crack you had this ridgeback formed going along that crack. And a lot of times you'll have what we call feeder veins coming off the main ridgeback, all in parallel like this. And these feeder veins are also cracks which are filled with magma. Okay, now, what is magma? Where does it come from? This is a very interesting thing, because now we're getting into the real part of the matter of where does gold come from. Now, I'm sure a lot of the geologists out there are going to disagree with me on this point, but it's not the first time they disagreed with the Northwesterners up here. See, you had two theories going on up here in the Copper Country. The Copper Country was the world's first and greatest industrial mining activity in all of history. And we'll get into the formation of the copper and all that in a different video. We're going to concentrate on gold right now. But basically you had two theorists about where the copper comes from. And one theorist at the Michigan College of Mines, which is now Michigan Tech, one theorist said, oh, all the copper is from hydrothermal water coming up and bringing the copper salts up and then solidifying them or dropping them into nooks and crannies and solidifying or precipitating out into pure copper. Well, that's the biggest load of BS I ever heard. We had masses up here, 200, 300, 400, 600, 800 tons of the purest copper in the world, just pure copper. It didn't even need separating anything out of it. It didn't need post processing at all. It was so pure they could make it into anything malleable, especially your highest quality wire, directly, because it was so pure. Well, you don't get that from precipitating copper salts. You're always going to get some other salts in there. And besides, copper cannot be dissolved in hot water. It can only be dissolved if it's a copper salt of sulfur, or a copper oxide, a copper carbonate. It's got to be a compound. Copper does not dissolve in water all by itself. Neither does gold or quartz. But you hear these theorists, these idiot theorists, these were chimpanzees who got run out of this area because they were laughed out of the area because they said all metals are deposited from hot water. Now that's just total crap. There are areas up here that had huge extruded masses of copper, just pure molten copper that was deposited here, same as out in Arizona. Gold, a lot of the gold there is just pure extruded gold. If you look at the nuggets, you'll see that a lot of them look like they were hot and molten at one time. They don't look like they were precipitated out of some water compound, because gold doesn't make compounds. You cannot make a compound of gold or platinum or anything like that. You have to have an acid, a really strong acid, to dissolve gold or platinum. It's called iconoclastic. That's a combination of concentrated, like 70% nitric acid and 35% hydrochloric acid. You put those together, then you can dissolve gold, silver, platinum, anything. And remember, my name is not Jeff. I am not Roger from Oz. I'm Ken from Copperland. And like I always tell you, gold turbine products that we're designing and building will it'll transform you magically. From a 90-pound gold panning weakling into a beast of a miner. Now, if you want to be a beast of a miner, you want to get that gold, stay tuned. I'm going to show you how to get it. So, take care. We'll see you out in the gold fields, and we'll catch you next time on the next video. Bye for now.